Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about hybrid drivetrain. So let's dive deep into it. Now, what exactly is the problem? Well, we have engines and we have been making these puppy for 100 years. So we know it. And our engines love to make energy out of the fuel they drink. As simple as that. Like be it jet engine, be it combustion engine, whatever have you, you give them fuel, they make energy out of it. Basically, the chemical energy, chemical potential energy that is there, you can get into physical energy with waste heat. So it's awesome. It works. It's a known technology. However, they do have one issue. They are very picky about the drive range, meaning if you give them variation, they are like, nope. For example, you take a jet engine. Jet engines are very precise devices. They are designed and fine-tuned for throttle level operations, meaning you go do whatever you need to do if you are in emergency. But if you are driving it, basically you took off, you are at cruising altitude, set the engine throttle to 80% and forget about it. Do not touch it. Do not tamper with it. Just let it go. Just let it go. Do not go fast and furious on it. Do not do that. They don't like it. And if you do that, like for example, fighter jets, even A, they don't do that. B, if they do that, their maintenance time will become shorter and shorter and shorter. Basically, gap between maintenance. And internal combustion, you can have an engine that can, at its peak RPM range, basically at its most, not peak would not be correct term, at its most optimum range, where it's like, for example, let's say the RPM is 2600 RPM, it's like, awesome, I got you back, I'm gonna give you awesome mileage. It's super awesome. But here's the, if you go wing 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 on this, like fast and furious on it, your mileage will go bye-bye, disappear. You don't have mileage. You will not even know what happened to your fuel balance. It will just go poof. So that's one of the biggest problem with all our engine system. It works, it's a known technology, it's super awesome, super reliable, and even efficient also. But here's the, we never able to translate that lab efficiency to real world. The primary reason for that is variation. The more variation you have of the load, the more mileage goes bye-bye. So real world creates a scenario where we have only variation. If you're driving a plane, it only has variation. At least it has the benefit of just high altitude and bit of stable environment there. And whenever you are talking about something terrestrial, for example, vehicles, they have multiple different ranges. So what the hell they're supposed to do? So we need something what we call as buffer or reservoir. For example, you look at a water dam. There is no river known to man or ever possible that will be like constant flow the end. That will never happen. You will have some days that has lot of rain, sometimes which has lot of drought. So you'll always have variation. But how the heck dams gives you constant power output? And that also on throttle, on demand, because they have a buffer. Basically, they have pseudo level of battery. And that battery charges up, and then you drain from the battery. So you are decoupled it. If you direct drive that puppy, it's not going to be very awesome. But if you indirect it, you put a buffer in front, you get efficiency. That's the how we're going to solve the problem. So what's the solution? Solution is engineering term, decouple the engine RPM from drivetrain. So however your wheel RPM is, it should not have direct marriage to basically your engine RPM. Through a gearbox is still direct coupling. Of course, you are changing the ratio, but it is still coupled, meaning if this stops, this stops. You can disconnect it by clutch, but all you are doing is just like, hey, on or off, or a clutch is on or off, and gearbox are just ratios, but they are still directly coupled, meaning rotation here is directly coming from here. It's not decoupled. We need to decouple that puppy. So what you need is basically engine that is driving a generator. That generator is generating the energy. That energy is driving the motor, and that motor is driving your drivetrain. For example, exactly like a locomotive. So back in the days when, as a late 1800s and the very early stages of 1900s, people figured out diesel engines are awesome. Everybody's like, yeah, awesome. But they were like, okay, let's make locomotives out of it. Let's go off steam and let's make locomotive out of it. Problem was they made engines, they were powerful, but gearboxes were like idiotically heavy and super duper hyper unreliable. So that was the issue. It's like, what the hell they're supposed to do? So back in those days, they figured out, what if we can decouple it? Basically, run a system of electricity, use that electricity to drive it, decouple that. And that's the backbone of what we call hybrid drivetrain. And these are the two configuration. If you have studied till class 10, there's a very good chance you must have studied that we can apply resistors in either in serial or in parallel. Same thing happens here. You can have a serial energy connection or you can have parallel energy connection, meaning energy can take two paths to reach the same destination. So that's the whole point. So you have engine, you have generation, you have a motor that converts your electrical energy back into rotation, and that rotation drives your drivetrain. Now you can add battery. Batteries are not necessary here. Let that be very clear. That's how locomotive works. You do not need a battery, but you can add it for more load variation or energy recovery systems. A battery is optional. And sizing of battery is directly dependent on you. For example, if you are designing a plug-in hybrid, you may design a bit bigger battery, or if you are designing something that is only there for mileage efficiency, you may try to reduce the battery size. So there is a lot of variation, and based on the variation compensation that you want, you will size your battery banks. And you have two options: serial, like this, basically engine, generator, charger, charger to batteries, battery to converters, converters to electric motor to drivetrain. Or you have parallel, basically battery, converter, electric motor to the drivetrain, reservoir as in like fuel reservoir to engine to directly drivetrain. So you have two of these approaches. These are the solution how we figured out how to get the most mileage out of the known quantity of energy that is fixed in a fuel. So let's start with parallel hybrid. Now parallel hybrid is basically if engineer got too much budget and too much weight. So engine can drivetrain using two parallel methods, two parallel modes of energy transmission, and both can happen at the same time. This is very critical, this is very important. This is why people want to make this, is that it keeps component size smaller. For example, you buy this puppy. This puppy claims 500 horsepower. Now here's the, does it have an engine that is 500 horsepower? No. Then it's like, why the heck they sold it you as 500? Well, they know for a fact that even if you are driving in F1 circuit, no engine is running at 100% power at all time. It will just go boom if they do that. And not to mention, driver will most probably go up. So for that reason, everybody has a drive variation where they're gonna at corners, they're gonna slow down. At straights, they're gonna go YOLO on it. But that's the real life. And in real driving scenario of real town traffic, most of the time you're never gonna touch 500 horsepower. However, because they specified it, they have to deliver it. So how they deliver it? They have 300 horsepower of internal combustion engine and 300 horsepower of electric motor. So they can drive both of them together and give you that 500. Or they can even overdrive you as like, hey, this is a 500 horsepower system. Drive it and people are like, dude, it feels like 600. Yeah, because it's actually giving you 600 mechanical horsepower. So it can be done, meaning you can keep all your components small. That's desirable. Smaller engine, less cylinder, awesome. Smaller motors, awesome. Less copper consumed, super awesome. Everything is awesome there. And power can be boosted using parallel method, meaning you can direct drive using your engine, or you can direct drive using your motor, or you can make both of them make love at the same time and voila, drive it. Or in some scenario where somebody smoked too much weed, they have tri-drive system, meaning energy can be coming from engine, it can coming from the engine motor generator unit and the motor generator unit that is for primary driving. All three can dump power into the wheels. Basically, your car that's supposed to be 500 horsepower, it can go as high as like 600, 700 horsepower. So basically, if you press the pedal to the metal and your computer detected you really want to go, it will do all the checks, it will do all the diagnostic. Be mindful, all modern cars have what we call drive-by-wire. So it's not only detecting what is the variation, basically from 0 to 100, where are you in the, like basically throttle pressure, also detects the amplitude, or not amplitude would not be correct term, basically the velocity or g-force, yeah, how fast you are pressing it. So if it detects that you are pressing it fast, that it will receive as a signal that's like you want to go, like you really want to go. So it's going to do all the checklists, basically engine temperature checklist, go. It's going to check the motor temperature, rotor temperature, stator temperature, all that. It will do all that, and then it's going to open the floodgate. Basically battery will be discharged at exponentially higher rate, and then motor drivers will be like, go YOLO. So engine, YOLO. Engine, motor generator unit number 1, go YOLO. Motor generator unit number 2, go YOLO. All three dump power into the wheels. So your wheels are like, whoosh. So it can be done. That's awesome. That's the desirable part. Meaning with small system, you can sell people a unit that is like, damn, this feels edgy, this feels smart, this feels what we call furtila, as in like very snappy, very like, very snappy. It feels like a Jedi. So that's awesome. However, it breaks engineering's first rule. The engineering's first rule is complexity is the enemy of reliability. You have this much love going on, yeah, good luck with that. Like good luck with that, like genuinely good luck with that. And if you are like, hey, why I see more electric car than hybrid car, even though hybrid car is supposed to give you best of both worlds, meaning if you are driving from home to office, drive directly on electric system, to not even use your fuel system. And if you are going on long range, just use the fuel system. Companies made it. Company have been making this for like as early as 2008. So why the heck we do not see these things? Again, they broke the first rule of engineering: thou shall not have complexity. These things, this mechanical marriage system sounds easy, and again, if you look at it, it's just like, oh, this is just a planetary gearbox system. The Toyota system is what we call electronic CVT, meaning it does not even have gear. And this is a Honda old variation where they had actual gearbox, so you can have gear number 4, gear number 3. After gear number 3, it will be like, not after, as in like before that, it can directly use the motor itself. So if it detects the battery has the charge, it's like, I'm gonna drive it. Basically, you are pulling out of your garage, it's like, hey, battery has charge. Yes, battery has charge, so drive it on that. So once you drive somewhere, and then it's like, okay, battery charge is going down, now you're pressing on the accelerator, then it's going to use that motor itself, motor generator unit itself, to spin up the engine. Once the engine is fully armed and ready, you run on engine after that. So that's a simpler way of doing it, but this system is like hyper complex, and that's why the cost of these things are not as low as you would think. You would think, hey, it's like it does not have big batteries, and what's people told you? Battery is the expensive part. It's not so. Complexity is the expensive part. Parts count is the expensive part. You always want lower parts count. Like flat out from a manufacturing point of view, it's not the thing that is expensive, it's how many things you have that makes it expensive. So having this many hassle thing, the wiring, the electronic circuit, I'm like, I do not even want to talk to the electrical engineer that designed this puppy. It's like, I worked for like freaking 10 years, and I am not joking. It may have taken that long to make the A6 capable enough of handling these 3 output systems that can all act as an input system at the same point. So this is parallel hybrid. Awesome technology, looks amazing, does give you overpower, but reality is like super awesome to buy, but God help you if you have to maintain this puppy, or any one small thing breaks into this. So in principle, best of both worlds. Side effect, reality is like, worst of old world. Chevrolet Volt, poof, because of that. Then we come to the daddy. The daddy is serial hybrid. Now, this puppy has one energy path, meaning energy comes from your chemical fuel, whatever it may be it hydrogen, be it seaweed biofuel, be it diesel, whatever have you, go, you'll own it. It goes to the engine makes it into mechanical power gets converted to electrical power, that electrical power goes to the drivetrain. As simple as that. For example, you take, let's say, World War II. You have a submarine. How does that submarine work? It has a diesel engine. Diesel engine is running on the air, is directly taking all the air in, running the power. That power is going into these big daddy batteries. These batteries are storing it, and then they are powering the surplus to the motor. Motor is driving the submarine. Everything is awesome. When you have to go underwater, you turn off the engine, batteries are like, I got you back. So that's how we have serial hybrid. This is the most oldest system with a battery system, and if you remove the battery, you take the battery, you eat the battery. This is how you get Locomotive, and that puppy is the alternator. So whenever you hear people talking about like 6,000 horsepower, where is that horsepower going from? Basically the engine, that you can easily see, oh, 16 cylinder of diesel, GG amount of power. That's awesome, that you can understand. But where the heck that power is going? That power is going into these puppy, which we call alternators. Now alternators convert that electrical, basically mechanical torque into electricity, electrical wattage. That wattage goes into, back in the old days, directly used to go into basically DC control circuit, and DC control circuit used to directly drive the motors. Awesome, does work, super awesome, super reliable, made diesels into the de facto gold standard of locomotive reliability. Awesome. And whenever you hear people talking about like electric locomotive, you just yeet this puppy out and yeet the engine out, put a transformer there. Nothing more than that. So inherently it's the same aspect. But part sizes are huge. That's the consequence. When they say 6,000 horsepower, that means the engine actually may be around 6,500 horsepower. The alternator may be 6,200. Like, everything in the last chain, because people can count it. Hey, I gave you 6,000 horsepower. This should be the tractive effort that you sold me. I'm measuring the tractive effort. It's not that. They're gonna boom you. And be mindful, the people who are on this level, they have pockets. They can actually boom you in court. So it's like, hey, let's overbuild this. So components are much huge. And when you're talking about submarines, like this is a lead acid battery like that. God damn it, like this is huge. So every component is designed to work at max power. It does not have like 500 to the customer and then it's going to overdrive it. No. It's like 500 to customer means 500 to the customer. And that means 24/7. So your engine is designed in such a way that it can operate at that load continuously. Your alternator on that load continuously. Then it drives the system. Now back in the days, again, this technology is ancient. We had DC generators. That's why back, if you look at very old manuals of engines, you will always find they will talk about DC generator, or they will have a short-term generator. Nowadays, you will find alternator. The reason for that is we developed silicon technology very early on, and then we figured out alternators do not need brushes. Brushes used to catch fire when you have this sort of high density there. So to stop that wear and tear and fire hazard, they're like, what if we use alternator there? And we had bridge rectifiers to smooth out that AC into DC. Awesome. But the motors were still DC. But be mindful, motors could be 1000 horsepower rather than 6000 horsepower. So DC brushes that were there, that was far more manageable compared to this puppy. So that's why we made a jump from DC generator to AC alternator was very quick, very early on. Like India, from independence, most of the locomotive that we got is basically AC alternators. However, what about the motor itself? That motor jump from DC traction motor to AC induction traction motors, those took much longer because it does require super duper hyper expensive inverter units. But again, nowadays we have that, so you have no brushes. So this is a very simple system. There is no complexity of power sharing and all that. Power sharing is only there in submarines. But even in submarines, I have never seen any manual where they are specifying that they can overdrive it. Most likely it does make sense to have the overdrive functionality, but it will overheat the motor. So it can be done. Now, what about the battery size? So let's assume you are talking about an EV, pure EV. That will require, let's say, 30 kilowatt hour of capacity to give you a good useful rate. Just go with that number. How low you can make it when you are talking about parallel hybrid? When you are talking about parallel hybrid, you can make that puppy as small as 5 kilowatt hour. That's a very tiny battery. That's like such a tiny battery that you can put it below the bottom seat and nobody would even notice it. That's how small that is. But then, like, when you're talking about this, again, it does not need to be 30, but it still needs to be like 7 to 10. So it does require a bit bigger battery because, again, one energy path. So path has to be 6-lane, strong path. But this is a much better, much more practical, much more time-tested known technology. Serial. You just energy produced, converted, stored, used. The end. You do not have sharing dance of gearboxes and other gearboxes and another gearboxes, another clutch boxes. There was some hybrid design that had freaking 3 clutch packs on an electric system. This clutch packs, 0. So this is serial hybrid, much better, much more awesome, daddy design. Then we come to what we can expect in the future. Well, reality is ICE engines are not going anywhere anytime soon, or maybe ever, practically speaking, because here's the deal. If you really want to take care of environment with minimal downsides, the seaweed biofuel is the only solution. It gives you solar energy converted into chemical energy with all the benefits, and it's carbon neutral. So it's not going. And not to mention, when you're talking about any flight applications, yeah, forget about electricity. So ICE engines are here, but if you have to do it, like you have to use ICE systems, why not increase this efficiency? Why not increase this output and mileage? Wouldn't that be desirable? Like from an economics point of view. It's like, think about this way, hey, this truck is a bit more expensive, let's say 20% more expensive, but it gives you better mileage. And that mileage is so much that your return on investment on that 20% extra could happen as quickly as, let's say, 1 year. You'll be like, shut up, take money. There is no discussion after that. Shut up, take money. So we want to do this. Now, it does support, from a manufacturing point of view, it does support modular manufacturing. For example, the companies that did a serial hybrid in basically car system, they were like, oh, people do not want worst of both worlds. What if they just want either a combustion system or directly this? They're like, okay, eat the combustion system, just use what we had. In the electric system, just make the battery box bigger, throw away everything else. It did not took away anything else. So it was very simple from manufacturing point of view. And this is another system European Union is working on their ass off on, that is that they want to have what we call electric highways. They're gonna have overhead wire, positive and negative, and just gonna power that system. Again, if you have a serial hybrid system, you can go on it. And they are so serial on this, is like the company that is building this, they can give you offer where you can have CNG driving it, you can have hydrogen driving it, as in combustion engine, you can have ammonia driving it, you can have battery power, and you can have normal diesel. I'm like, that's a serial hybrid system. If you have a serial path line, you can change whatever the hell you want to change there. So it supports modular manufacturing. It allows you to scale every part independent of each other. And it won't have interlinkage of gearboxes. I have linked a very amazing YouTuber, and he's not a YouTuber, he's a professor first. He does YouTube on the side, Auto Viewer Show, and he has shown taken apart gearboxes of these puppies. You'll be like, what? It's bonkersly complex. So it supports a modular system, and you get the choice. Like, for example, this is an Indian company that is working on right now, early stages, that they want to build micro turbines. Those turbines are like basically under megawatt power rating. So half megawatt. and that's going to power the motor generator unit, that's going to power the batteries is going to power the traction motors. Simple, elegant. And let's say that jet turbine system does not work for some reason, or let's say government switches from jet turbines to, let's say, hydrogen tank, no problem, swap that part out. Completely independent, completely modular. So that can be done. So how can we make this system or journey far more cost effective? With utilizing modern technology. For example, when you have weight constraint and size constraint, you want to make things as compact, as dense as possible. So solution, PCV axial flux motor generator unit. Now be mindful, every motor is a generator, every generator is a motor. These are interchangeable. You never have to like, oh, I bought a motor, so that means I have to buy a generator. No, it's a generator. You just know how to drive it. Especially if it has magnet, that's not even an issue. We can do that with induction motors. So if you have magnet, it's child's play. If you have induction motor, it does require a bit of trick engineering with motor driver unit, but it can be done. So you take PCB way, axial flux motor. Why? Axial flux has much higher density. PCB way have super duper high density in terms of stator, and then you can achieve really, really compact system. Now, ideal scenario would be you take a normal car, let's say 500 horsepower car, and you throw away the transmission system. You keep everything, but you just throw away the gearbox. What would be the weight of that gearbox and the size of basically how many liters and what is the weightage? Generally, it will be quite big and quite heavy also, because again, that much torque, it has to withstand that. So you put a motor generator unit and motor driver unit, motor generator unit number 2 that will be connected to the wheels. And if the weight and size of that is below the threshold of that volume that you removed, that would be GG. That's the desired aspect. It's kind of easy to do that in trucks have so much surplus area, but in cars it's a bit difficult. Not difficult, bit difficult. It may require a bit of clever engineering, but it can be done. And what's the benefit? Low emissions. If you take an emission output of an engine that is running at constant RPM, it's much lower compared to an engine that is going wing wing. So fundamentally lower emission, everybody will be breathing better in cities. And energy recovery, which is really desirable for trucks, because trucks have very high variable in their weightage. For example, a car weight does not go too much up or down, especially in EV scenario where you have like, okay, 2 people are sitting or 4 people are sitting. It does not, weight does not go too much up and down. Trucks can have like X weight, and when they are hauling some big daddy, it could be like 4X. So brakes take lot of heavy loading. Now locomotive also have that issue, because again, a locomotive could be just a locomotive, or it could have 4 freights behind it, 8 freight behind it, 30 crates behind it. At that point in time, how the heck you handle it? You don't. You just run your motors as generator and dump all the energy into a resistor bank, and you cool the resistor bank. So basically you are just using all that kinetic energy into heating energy, and you do not have to wear down your brakes. So that's desirable. That's like short uptake money. And here in trucks, you do not need to do something that drastic. You can just dump all that excess energy into the battery banks. So this is a very amazing use of technology with what we have already, and we have been using it. It's just somebody figured out like to make parallel hybrid for some reason. So this was my presentation on hybrid drivetrain. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.